When you ask a chatbot to generate an answer, the immediate, perfectly phrased response feels like a finished, absolute technology. But the code generating those words is actually built atop a fractured understanding of our universe. This diagram shows the first major historical schism in physics. On one side, Albert Einstein modeled the universe as an empty, four-dimensional geometric fabric. On the other, Nikola Tesla insisted the cosmos was filled with a dynamic, energetic substance called the ether. A second massive divide occurred in quantum mechanics. John von Neumann formalized a rigid, objective mathematics for reality that exists completely independently of us. Conversely, John Archibald Wheeler proposed a participatory universe, where the act of observation is what forces reality to crystallize into existence. The microchips and algorithms powering our digital lives are now providing the experimental proof needed to resolve these century-old stalemates. This illustrates the von Neumann architecture, a centralized unit executing binary bits sequentially. Routing data through a single pathway creates the von Neumann bottleneck. The biological mirror is the cheetah. Visual data routes down a restrictive spinal cord, optimizing for terrestrial speed while sacrificing lateral flexibility. Look at the left panel of this graphic to see how classical computing navigates a complex problem. Lacking a macro perspective, it uses brute force to test every path sequentially. It sprints down a corridor, hits a dead end, and reverses. This electrical resistance generates immense heat, forcing the hardware to engage in thermal throttling, downclocking its own speed to prevent the system from melting. This bounded step-by-step methodology aligns with Albert Einstein's macroscopic universe. Einstein gave us a deterministic spacetime fabric bound by absolute speed limits and rigid local realism. The reliability of classical devices demonstrates that geometric rules of reality are real, but brute force alone cannot transcend the unbreakable walls of the universe. To bypass those unbreakable physical walls, engineering had to move into multidimensionality. We built quantum computing. This diagram highlights the biological equivalent of quantum compute, the eagle. Inside the avian retina, specialized light-sensitive proteins create an entangled pair of radical electrons. This allows the bird to sustain quantum states at warm temperatures, visually processing magnetic gradients to see the entire probability space of the Earth's field. This image maps a 2026 discovery where researchers identified over 17,000 distinct topological signatures hidden inside a single entangled photon. By manipulating the orbital angular momentum of light, they found that a particle of light carries a 48-dimensional structural alphabet. This dense, energetic complexity validates Tesla's concept of an active ether. Modern physics now defines empty space as the Higgs field, a dynamic, space-filling medium full of zero-point energy that gives matter its mass. Quantum computing proves that space is not an empty geometric void, but a multidimensional ocean of energetic potential. This diagram demonstrates our final paradigm, artificial intelligence mirrored by the octopus. AI abandons centralized routing, distributing its neural network through millions of parameters. Like an octopus pouring itself through the cracks of a maze, AI adapts its internal topology to permeate the structure of a problem. This chart directly compares Wheeler's participatory universe theory to AI engineering. Wheeler's it from bit theory states that every physical object derives its existence from binary yes or no information. In AI, this is realized through tokenization, the disintegration of continuous human reality into discrete mathematical shards. Before a prompt is entered, the AI's latent space exists in mathematical superposition, containing the potential for billions of responses. When you submit a prompt, you act as the observer. Your query forces the AI's softmax function to collapse those infinite probabilities into a single definitive response. This diagram illustrates the current crisis in this system, the key value cache bottleneck. To maintain the observer's context, every process token must be stored as a high-dimensional vector in high-speed memory, which devours GPU capacity. This graphic shows Google's TurboQuant algorithm, which addresses this memory crisis by synthesizing Einstein and Tesla's spatial geometrines with von Neumann's math. It rotates traditional data grids into predictable polar coordinates, using a radius for magnitude and angles for direction. This reduces the memory footprint by 6 times while maintaining flawless precision. By geometrically compressing the memory of the observer's history, engineers built a machine that physically rearranges its internal math to sustain a negotiated participatory reality. Look at this final graphic. We have moved from building static calculators to engineering functional mirrors of the universe. By combining the grounded speed of classical logic, the multidimensional perspective of quantum physics, and the fluid adaptation of neural networks, we have synthesized the competing theories of the last century into a single cohesive tool. In both Wheeler's universe and AI architecture, the system responds first to the system prompt, the baseline identity of the observer. The machine, much like the cosmos, responds entirely to the identity we project into the void. A moment of wonder. If our technology is a high-dimensional mirror that only takes shape based on the signals we provide, what identity are we projecting into the void of humanity's own latent space?